Okay guys, today I would like to speak a little bit about the mixer. I think the mixer is maybe the most important part of programming our models. So, before I go into the details about how the mixer works, I would like you to see this, so you can understand more or less how the mixer works. So the order of processing of a mix is: first you obtain the source value with exponent while rates applied to sticks. So before everything else, you can apply exponent while rates to the inputs. Then add offset. Actually, we're not going to use this offset. I'll explain a bit more later. Then delay and slow is applied. After, curve, all the curves and differential if you want to set it. Then comes the weight. Weight is the travel and the amount of the mix. Then the late offset. This is the offset that we're going to use and I will explain a bit later. Then after the mixes, subtrim is applied, limits, and safety switches if set. This is all the steps. The controls go since you moved your sticks until the signal goes out through the air to your servo, to your model. So here we have the mixer, and I'm using Ape Sky to show you because this is easier to understand and easier to show. But to get to the mix on your radio, go to the menus and mixer menu, and to edit the mix, just go down to the mix, to the channel you want, and just highlight it and press menu, and the pop-up window will come up and you just select edit. So what we have here, we have the edit menu for the mixes. We've got the source, we've got the weight, which is the quantity of the amount for the travel for that particular mix. We've got the offset. We're not really going to use the offset, we're going to use the late offset. Here it says fixed offset, but it's a typo here. Include trim. That means if it is a stick or a main control, you want the trims. If it's a mix like landing gear or lights, so you don't really need to include trim, so you can just uncheck this. Then you got switches, switch to activate mixes. Then the flight modes, we'll see this later. You got the curves, you can select curve or differential. You set the value. Warning, so when the mixer is active, you can have a warning. It's some kind of audio. And then multiplex. Multiplex is how the mixer actually works. How that mix is going to work. So we have add, we have multiply, and we have replace. More on this later. Then we have delay and slow, up and down, and delay up and down. What is delay? Delay, it's normally it's attached, of course, it's attached to a switch. When you flick the switch and turn this mix on, the mix will not go on immediately. It will wait for delay time, and only after then we go on or off, depending. Slow is a bit different. Slow, the mix, when you flick the switch, the mix will go on immediately, but it's like slow motion. it takes some seconds until it's fully on. For example, landing gear with slow motion. So we got the source, we got rudder here, and we got the weight, a weight of 100. So what is really weight of 100? Let's go to the simulator here. Means that we have 100 to one side, you can see the numbers there, and 100 to the other side. I'm going to press Alt X here so we can leave the stick. One side you can see that is minus 100 and 100, and we have 0 in the center. If we change this number to, for example, 50, you will see that with the full movement of the stick, we have 50 to one side and minus 50 the other side. So the weight is the travel for both sides of the movement. So a weight of 50 is actually plus 50 and minus 50. We can also invert the direction of the servo by inserting a negative weight. So you go here, put minus 50, we have a negative weight. So you will see that the servo will be reversed. See? And this is the weight. This is how the weight is. This is the quantity of travel for the mix. So let's put it back to, well, let's leave it in 50, but plus 50. So now what we have? Now we have the offset. But as I said before, we're not going to use the offset. We're going to use the late offset. And I explain why. This is a post from Mike in the forum, in the OpenRC forums. He says, without late offset, the offset field is added to the source value before the weight and differential is applied. This means, for example, if you have a weight of 50%, then the maximum offset is reduced to 50%. At 100% offset, you can get one end of the output range to 0, but not beyond. The late offset adds the offset value in after everything else. So after the weight, after slow, after differential, after curves, after all that, yeah? So you still get up to 100% offset. You also know what the offset value really is, instead of needing to back calculate what the weight has done to it. With this, you can move the active range where you like. Example, weight 25 and offset 25, late offset of course, gives you an output from 50 to 100%. You can't do this directly without the late offset. I think the late offset is what should have been done originally. It seems to make more sense to me. And then he says, I have added an option to avoid upsetting existing model settings. That means if there were not other people already using the normal offset, I think he would have already removed it, and I think he should really. So he said here, example, weight 25. Let's see what it confirm what it says here. Weight 25 and an offset of 75% gives an output from 50% to plus 100%. So the 50%, well, for 49.9 to 99.9, which is 100. And why? Because they have an offset of 75%. You can see here, 74.9. So we shifted the center of the movement. When the stick is at 0, will actually be 75% offset. And then the weight says 25%, so it's 25% actually to one side and to the other. So we are just shifting the center, we're shifting everything to one side or to the other. For example, if we change here to 50 offset, and for example the weight to 10, see, you can see that the center has gone to 50 and we add only 10 to one side positive and 10 negative to the other side. So we have from 50, sorry, we have plus 10 movement, which get to 60, and minus 10 to the other side, go to 40. And that's how late offset works, and it makes much more sense. For example, if you want just the rudder to go only positive values, that's very easy. Just go here, put 50% offset and 50% weight. That means, why is it not working? I press, yeah, okay. So we move the center 50% and we give 50% weight, so it's 50% to one side, which is 50 plus 50 is 100, and 50 minus 50 is 0. So we have the stick but only giving positive values. We can of course also use negative values. You can put, for example, here an offset of minus 50, and that will give us the other side of the offset to the other side, to the negative side of the travel. We have 50 and 50. So we add 50, we add the weight to one and other side. So it's 50 to one side, it makes 0, and minus 50 minus 50 is minus 100. I think this is quite easy to understand. Of course, you can also change the direction of the travel. You can see this follows the stick movement. If we change here the weight to a negative value, you will see that it changed direction of travel. The same applies if I put a positive value to the offset. So the other side, see, but the weight is negative, so the direction of the servo movement is reversed. It's quite nice actually. I like this feature. For example, here, to have a positive, let me make a positive value here again. So to have the rudder going only on positive values, if we were not using, this is logical, because we've got 50% offset with 50% movement, and you can see that we know we are getting exactly the value we shifted the channel here, and we are getting exactly the weight value that we set. If we use the normal offset, it's just to show you, because I don't even want to talk about it, because this is see, we get this. So to make only have positive values, we have to give here shift 100 and leave the weight of 50, and like that it works. With a fixed offset, with a late offset, if you just put a weight of 25, it would just go to 75 and to 25. But with here, if I just change the value, the weight to 25, this is gonna get completely absurd value. What's happening here? See, we don't get what we expect to see. If I use the late offset, what's happening to this computer? Now it works. You can see that we get exactly what we set. 50% offset plus 25% movement. Wait. And that's what we expect to see. I hope I managed to explain correctly how the offset or the late offset works. So one thing I would like to show you is the multiplex. Add, multiply and replace, and that's next. Okay guys, I will now explain what is a multiplex mix, an add mix and a replace mix. We can find the multiplex here. This will dictate how the mix behaves, or what the mix will do to the lines above it, that specific mix line. So we have an add mix, a multiply mix and a replace mix. We will start by add. So what does add do? Let's add, we have a rudder channel here, program, as you can see. Let's add something to this mix. So the mix is already in add mode for the next mix, so we just go here, add, new mix. It's add already. Let's add, say, 20%. So what will the mix do? Now just plain 20%. Not rather, made a mistake, sorry. Just like this, 20% full. Full means just a static value. Full and half are just normally static values. Full goes from -100 to 100, and half acts only on half of the travel of the channel. I will explain this later. So what did we do here? We have 100% rudder, but we added 20% to the mix. So we created an offset. So as you can see, the center now changed by 20% because it was added to the previous mix. We can, for example, do something useful with this. We can, for example, mix some aileron. So just select aileron. People use these to compensate a turn with a bit of rudder when they turn using the aileron. So we select the switch here as well. Let's put the switch rudder, for example. If I can find it. Here it is. So we are adding to the 100% rudder mix, we are adding 20% aileron when the switch rudder is on. So now it's not adding anything because the switch is off, but as soon as we turn the switch on, you will see that we will add 20% aileron to the rudder channel. See? I'm going aileron added, and we still have movement on the rudder based on that little aileron movement that we added. Of course, when you don't need the rudder to compensate anymore, or the aileron to compensate in the rudder, just turn the mix off and everything is normal. Aileron doesn't control the rudder anymore. This is nice. So another example of add. We learned a bit about offset before, or the late offset. There's another very interesting mix, which is sometimes when the plane there's the incidence of the motor, so it's not quite right. When you give gas, when you give power, the plane tends to climb or the plane tends to descend. Let's imagine that the plane tends to climb. So what we want to mix a bit of down elevator when you open the throttle. So now how do we do that? With an add mix and with a little bit offset, because you want only positive values, right? So let's go to our throttle channel here. For example, channel 3. We should throttle. No, sorry. We go to our elevator channel. Let's delete this. Add elevator channel, which is elevator here. Because we're going to act over on the elevator channel. So we have our elevator here. Only one side. Sorry, it's morning here. And it's reversed. Let's do the same here on the channel. I'm going to add a little mix here. Just because I want both, because I got split elevators here. And I want the channel 6 to do exactly the same as channel 2, so I just add a mix with channel 2. See, again, add a mix. So this one is working okay, the other one is reversed, so I'll just go to the limits and reverse channel 2. That will do it. Yeah, they're both working same direction now. So, back to the add mixing. I want to add a bit of down in elevator when I open the throttle. Say 10 to 20% or so. A little bit. And how do we do that? We create another mix on the elevator channel, another add mix. So here, we leave this in of the multiplex here and add. And we put, say, 10% weight and 10% offset. This will give us an offset of around 10% each way with the throttle channel. I made a mistake here, should be throttle, not rudder. It's morning here, so I do apologize. So okay, as you can see, you have on channel 2, but this is going on the wrong way. It's going the wrong way. No, actually it's not. It's going the right way because you want it to go down. I just reversed channel 2, that's why. We want it to go down, as you can see on the servo, when we apply the throttle. The more throttle we apply, the more the channel will go down, as you can see in the video. See? We can increase a little bit more. So this increase until 20%, because 10 to each side, if you remember, got 10% offset plus, and then 10% of means 10% plus, 10% minus around the center of the offset, as you can see. So, and this is a compensation with negative elevator when we open the throttle, and the more gas we give, the more the elevator goes down at the center, just to compensate. So it doesn't want to go up anymore. Okay, as a third example, we'll create another add mix. That means we're going to add one control to another control. In this case, we're going to add elevator to aileron and aileron to elevator. So what we're going to do, imagine that the tail of the aircraft here is a flying wing, and we need some aileron mixing, which is elevator and aileron at the same time, because you only have these two controls. So what we're going to do, we're going to channel 2, we have the two servos, one is channel 2, the other one is on channel 6. So we're going to add elevator on both, channel 2, and we're going to add elevator also on channel 6. You can see we have elevator on both, but we need some aileron, so controlled by the same servos. We need some aileron mixing so we can turn as well. So what we're going to do, we're going to add aileron to the same mixes. So just go here, add aileron, add aileron to channel 6 as well. So as you can see now, both aileron stick and elevator control the servos. But the thing is, when I give aileron to the right, both are going also up and down, right, left. So we need to reverse the servo. When we go up and down with the elevator stick, that is correct. So we have to reverse one of the ailerons, which is channel 6, if I'm not mistaken. So let's reverse by applying minus 100. So now the correct movement. Yes. So we are adding minus 100 to the of aileron to channel 6. And here elevator is still correct. See? One thing though, we are adding 100% of each input. So what's going to happen when we add both full sticks? So we have to add 100 plus 100. That is 200 movement. That's too much, and it will be clipped because the limits are set to maximum 100. So as we can see, if we go put both up, you can see the stick is only 50% gone in both ways, up and right, and we already reached 100 here. Already reached 100, and it will clip, it will not move anymore, and we have dead point of the stick there. We have dead stick there. Doesn't move. So what we have to do, we have to reduce the weight so that the maximum of that both the result of the addition of both sticks will be 100. So we decrease the weight here to 50. 50. 50. 50, and the next one has to be minus 50, because remember we had to reverse the channel by adding a negative value. So you see that the output of the channels now will not be, the result will not be clipped. So we put maximum stick on both, and we'll see it will be 100 right there. So there we have level mixing. See? Right, left, and up and down. That's nice. We can go and fly our flying wing now. Another similar mixing is the V-tail mixing. We just use rudder instead of aileron, and you have a V-tail mixing. So that was the add. Next we will see how to work with multiply mixes. Okay, now we will see how does a multiply mix work. So here we have the rudder channel, you can see, and I have a weight of 80%. What I'm going to do, I'm going to add a multiply mix to it. This is a bit confusing, or people think, and I did think this was a bit confusing, multiply is a bit scary, isn't it? But actually what the multiply mix does is to scale the mixes above it in the same channel. The result will be a percentage of the mixes above in the same channel. For example, we have here 80% rudder, and we will add, in this example, we'll add a multiply mix, multiply here, which is of 50%, a static value of 50%. So I'm going to use full. This will scale the 80% down to half of the travel. So the rudder before went 80%, now goes only 40%. So what multiply is just to scale the mix above it. We can scale it down, or we can scale it up. For example, we can put here 125%. and you can see that now the weight goes to the resulting weight of all of it scale goes to 100%, because 100% is 125% of 80% of 80. So another example. So we see that the multiply mix scales the weight of the mixes above. For example, another example, we can make this variable, for example. So we just modify this here and we choose P1, for example. P1, here a value of 50 and a late offset of 50 as well. You already have seen how late offsets work. So what we are doing here is with P1 we have a variable percentage from 0 to 50. For example, here we have 50 no from sorry from 0 to 100. So because we have an offset of 50% and a weight of 50% on both sides of the offset, so we have 100% from 0 to 100% travel, because that's what's offset. That if I just delete this, for example, you see that P1 I have to make this add. You see that this is moving from 0 with the offset 0 to 100%, right? Okay. And now we add a rudder like we had before, 80%. This was just to show you. It was just to show you. You have to move this down here and now make this a multiply mix. So you saw that this line here adds 0 to 100%, right? So, and we are with the multiply, we are applying a scale factor from 0% to 100% on this line here, on this 80%. So 100% of 80 is 80%, right? 50% more or less will be about 40%, right? So 50% of 80 is 40. And here, of course, 0 is 0. So no movement, because we are applying 0% to the mixing above. So the result is obviously 0. Sometimes we use this to adjust. We can use a mix like this to adjust how much travel a control has in flight. For example, you have a plane with an elevator, and you don't really know how much control you should have on it. So you can use a pot like this to give it more control or less control in flight. So you can change how much control. So if I put like this, see, you change the maximum control, see? But one thing that is not good is to have 0% here. That's not good, because if by mistake the pot to 0, you have no control whatsoever. So what we can do about this? We can use another scaling. So use, for example, an offset of 75% plus a weight of 25. So 25 plus 75 is 100, and 25 and 75 minus 25 is 50. So we're going to have control from 50 to 100, as you can see here. So on the minimum, you have 50% of 80, which is 40, yeah? And in the maximum, you have 80%, or 80, which is 100% of 80. So even if you have put the potentiometer in the minimum, you will never have zero control. You have the minimum control that you want. So you can choose between this minimum control that you set here until full control here, and the minimum control. So you'll never have zero. So you can use this setting to, for example, if you think that you might have, you don't know if you have enough control on the elevator or if you have too much control on the elevator, so you can use the potentiometer here on your radio to give it more or less control. So it's not very difficult to understand. This is multiply, is just scaling. I thought before there was, must make calculations, multiply, and no. This is just scaling. That's what this multiply mix does. Just scales everything that is above it on the mixing. Okay, yet another example of a multiply mixing. We will add, this is add aileron, a bit of aileron to the rudder, and we will scale it, the quantity, with P1. So at the moment we have aileron on channel 1, which is the rudder channel. Like this is zero movement. With P1 we can have 5% movement of the aileron on the rudder channel, like this, 5% to each side, like this. Or 10%, sorry. So what we're going to do now, we're going to add the rudder, because I didn't add it yet, so I could show you what the aileron is doing on the rudder channel. So I add now 90%, because I'm going to add now the rudder to the value of this mixing above. So I'll add the position of the rudder. So now, sorry, wrong place, move down, okay. So now I have the rudder controlling the rudder channel, and I have the aileron controlling also the rudder channel, but in a variable quantity. You can vary the quantity that the aileron change the rudder channel. This is used sometimes, like we've seen another example before. This is used for when you want the rudder to assist your turn when you're turning with ailerons. So you just put a bit of aileron on the rudder, so when you turn with the aileron, we'll also turn the rudder a little bit. And like this you can control how much rudder. Use less control, less aileron, like this. Cool. Okay guys, here is one more example of the multiply, and this time it's multiply and add all together. This one is a bit more complex. This is for for a mix that could be used in IC powered, internal combustion powered models. And make the mix here for the throttle. Okay, channel 3. For example, you can see here on the simulator we have the throttle, and there's an option on Skyline X for the trim, because if you see now, the trim here affects also the top of the movement. So this is not good for IC powered models. We have an option in the setup which is called throttle trim here. We can just press this, and the trim now acts only on the bottom part, see, of the travel, so for the idle, setting the idle in the engine, right? And the top remains unchanged, whatever you move the trim or not, only the bottom, as you can see. So, what I'm proposing here is a mix, or what I'm going to show here is a mix that uses a pot instead of the trim. So let's start. What we're going to do, first of all, I'm going to move this mix down here. We don't need this for now. Well, I'll use it later, so I'm being lazy here, I don't want to write it again. So we start here with a mix add. We're going to use the late offset, throttle 50% or minus 50%, sorry, and an offset of 50%. Include trim? No, we're not including trim anyway. So, what does this do? Forget no channel 6, that's the other mix I had there. What this do is, this create an offset from 0 to 100 here, but inversely proportional. I think you say it like that. Sorry, I'm not English. That's not my mother language, so forgive me, please. Inversion, well, the opposite of proportional. I don't know the word. So from 0 to 100. Now we create another mix. This time is going to be a multiply mix. Multiply, no trim. And this time it will be controlled by P1. P1 is going to adjust the amount of idle we will have on the engine. So let's say some 40 and offset 40. Fixed late offset again. So what we have here now? Check channel 3. We have this, and the multiply mix will scale the first mix from 0 to 100. This will be scaled. At the moment is 0, controlled by P1 by the pot. So here is 40% of the mix, of the first mix, the mix above, and here is 0. So here we'll be adding no trim at all to the throttle channel, and here 40% of movement, there will be the trim. So what we have to do now, we have to add this, just move this up. to where it was, to the channel here. All we have here now is the throttle. Let me include trim, no. Okay. So, and this controls the idle. See? The top remains unchanged, look. This is very clever. The full power remains unchanged. And we have the idle speed controlled by the potentiometer. That's cool. Okay, now I've already set my motor there, my engine, but of course I had to reverse the servo and blah blah blah, so I created another mix. This is ready, so you can see it working. See the values, and I had to reverse it on the limits, see, and I have to decrease the amount of limits because the servo was just too much travel to the servo and much less on the engine. The controls was too much, so I have to reduce a lot. So here's the mix. It's the same mixing as you can see, and I'm just going to connect to the connected. And you can see here, and now changing the idle. See, the maximum stays actually untouched. Only the idle is affected, as you can see. I can even close a bit more this on the limits. Close a bit more the carburetor, like this, as you can see better. So this is closed, full power, closed, and now I can adjust the idle. Of course, all closed, it will obviously stop the motor or stop the engine. So we can control the idle here, and the full power remains unchanged. If I put the stick on full power and just control the pot, nothing happens, as you can see. So this mix is a bit complex. It's a mixture with add and multiply. At the end, I didn't explain, but I just added the 100% of throttle to the other mix we had before with the multiply and with the other add mix. It's a little bit complex, but if you play a little bit with it, you get to understand it. It took me a little while as well. So this was the third example for a multiply mix. I will explain now how a replace mix works. This is actually very easy. So imagine that we have the throttle channel here. Throttle, right? Channel 3. And we had a replace mix just like this. Full, it is a static value, yeah, of minus 100. So you're going to minus 100. Replace, and we have to choose a switch. Select the switch. Let's put throttle. Okay, what does this do? This mix will replace this one or every mix above on the same channel when I turn the switch on. So it's working. I take the switch on, and this mix here will force the channel to minus 100 and replaces the one above. As you can see, replace the other one and is pulling the channel to minus 100. This can be used like a safety switch on throttle. If you leave the switch, throttle moves again. With a switch, channel pulled to -100. This is a replace mix, and this you can see it because there is a little R here just in front of the mix. We can do something else. For example, with a replace mix, we have the rudder here, just another one with aileron, and replace. Add a switch like a rudder switch. Okay, and what's gonna happen? We have the rudder channel. You have the, I made a mistake here, sorry. I have to put the rudder, I forgot. I edited the rudder mix. I didn't add a new one. Sorry about that. So, like this, rudder, and then we have another one replacing the rudder mix with aileron and the switch. Why this always happen when I'm recording? Amazing. So, we have the rudder here. And my mouse is crazy as well. And when I flick the rudder switch, the channel 1 is not controlled by the rudder anymore, but is replaced by the aileron. As you can see, it's replaced. This mix with aileron is replacing the other one with rudder when the rudder switch is on. If I turn it off, aileron stick doesn't control channel 1, but the rudder does. If I turn the button on, switch on, rudder not, aileron controls channel 1. So this is replaced. It's very easy to understand. Well, I hope you guys enjoyed this video. I'm sorry, my mother language is not English, so sometimes I have a bit difficulties in expressing myself. Anyway, I hope this video was useful for you, and enjoy it and practice a little bit using IPSky, and happy flights.